Okay. Before we do convert degree to radian, radian to degree, I want to show you some cross multiplication. The cross multiplication, here is the example. Why it works, here shows. You see, $6, you buy 2 gallons, and 2 gallons of gas. And then if you want to buy 8.5 gallon, how much you should pay? You know, this one is in intermediate algebra or introductory algebra, easy to do. But right here, you know, we just do cross multiplication. We do 6 times 8.5 divided by 2. Then you will get this amount. Very quick. Why? You see, 8.5 times 6 divided by 2 is actually 8.5 times 6 divided by 2 in this way. That's 3. We know that. And right here, you can see 6 divided by 2 is, you get 3. 3 means $3 per gallon. Okay, $3 per gallon, you have 8 gallon and a half, so of course it's 8.5 times 3. You have $25, $25.5. I can prove this one in general, but I don't want to do that. I think you can enjoy that. Here is that I want to show you this way always work. Cross multiplication. Now here are 2 examples. One is that if you have 50 degrees, how many radians you get? You want to always remember 180 degrees is pi radians. Okay? And then you know cross multiplication, that's 50 times pi divided by 180. 50 times pi divided by 180. Cancel those 2 zeros. So you have a 5 pi over 18. That's the radians for this. Okay? So it's very fast and very easy to do. Now, here you have a 180 corresponds to pi radians again. And then if you are given radians, 8 pi divided by 9, then how many degrees you get? Again, you do right here cross multiplication. This one times this one divided by pi. 180 times 8 pi divided by 9, then the whole thing divided by pi. You know, 9, 180, this will give us 20. Okay, because you have 1 here, and we have 2 here. 20 times 8 is 160. You cancel pi upstairs, downstairs, so you have 160 degrees. So it's very fast. Okay? This will bring us to the end of the second topic. What is that? Radian and degree. Okay? Now, we'll go back a little bit to talk more about degrees. I will give you some examples over there. Okay? But right now, let's consider the third one. That's the length of the arc equals radians times the amount of angle. Okay? This is what we got. Probably you remember, recall just now, we did was what? Was the length of the arc divided by the length of the radius is the amount of angle. And then, you know, take r to the right hand side. By doing both sides, multiplying r, we get that. So you got to remember this formula. It's a very common formula later on in calculus. The length of the arc equals the radius times the angle. So it's S equals theta times R, or R times theta. Okay, so R theta S. So S equals theta times R. Okay, that's the formula. All right, that would be the third topic. Probably we can do the third topic and the fourth topic together to get another formula. Okay. Now, look. Look at this one example here. We know how are we going to find out the area of a disk. That's this one. The area of the disk is pi r squared. Okay, pi r squared. That's pi times r squared. R is the radians. That's the disk. But we know how large is the whole circle of the angle. That's 2 pi, 360 degrees. Okay? So basically, 360 degrees corresponds to this area, the whole disk. Okay? And you know theta, this central angle, corresponds to the area of this sector. Okay, theta is the angle. Okay, theta is the angle. And this angle is called central angle. Okay, so theta corresponds to this area. Let's say A. So theta corresponds to A, this area. But you know, if you rotate a fully circle, then you get this angle 2 pi. And then corresponds to this area pi r squared. Okay? Okay. Theta corresponds to this area of the sector. So you write theta A. And then if you rotate one fully circle, that's 2 pi. That's the angle, or 360 degree, corresponds how large of this sector. That sector is very special. It's the whole disk, pi r squared. Again, this one we can use the cross multiplication. Okay? How are we going to find out A? A equals theta times pi r squared divided by 2 pi. So pi r squared times theta divided by 2 pi. It always works. Okay? So then you cancel pi, so you have a 1/2 r squared and theta times r squared times 1/2. Okay? So A is the area of this sector, and theta is the corresponding angle, and r is the radians. Okay? So this is the formula to find out the area of a sector. All right. Now, with those two formulas in our mind, you see, length of arc is r theta. The area of a sector is 1/2 r squared theta. If you don't look at these two and this one, two downstairs, they are the same, r theta, r theta. You see that? You got to remember in this way. The area always is something squared. So if you put r a 2 on the shoulder of R exponent, then you have a 2. Okay? This is the way I remember. It's not really the consolation. It's the way you remember this. Okay, with those two formulas in our mind, we can do a question.